I'm going to hand over in a second to Professor Nick Wilson, who's doing the next talk. And we're just going to swap over the slides.
Kia ora koutou. My name's Nick Wilson, and this presentation is with my colleague, Matt Boyd. So we're looking at anticipating and managing threats from artificial intelligence and bioweapons. So first of all, there are actually a wide range of concerns about artificial intelligence. So while artificial intelligence appears to have enormous potential value, including in the health sciences, there are actually some major concerns. One is about potential mass unemployment, leading to societal disruption and increased inequalities. Risk of AI being used to facilitate state conflict, with such phenomena as robot armies, cyber attacks, and also concern that it will affect nuclear weapon control systems, and also bioengineered pandemics, which is what I'm talking about today in particular. But also there is concern about non-aligned AI also being involved in actual societal takeover. So one of the world's largest forecasting exercises was done a few years ago, involving large numbers of domain experts and super forecasters. And the outcome was that they were able to look at different catastrophic risks. And the catastrophic risk of greatest concern, particularly the domain experts, whose track record actually is better than the super forecasters in specific areas, was artificial intelligence, then a nuclear catastrophe like a nuclear war, and then third, an engineered pathogen pandemic, which is also potentially related to the artificial intelligence issue. But actually, since that forecasting work was done, the risks probably have increased. There's been more rapid progress with artificial intelligence, especially in the US and China, including ongoing release of open weight large language models. And the concern there is that with the open weight models, it's easier for people to disable the guardrails that have been built into the LLMs. There's also a lot of concern about the really extremely lightweight regulation of artificial intelligence by governments or the United Nations. And in fact, the United States government is in an apparent arms race, with AI, with China, and within countries, there's also very intense competition between the AI companies as well. Some of this has prompted also recently an open letter on the existential risk that could be posed by AI by 350 experts. Several of them were Nobel laureates who work in the AI area. And there's also a group called the Elders, and they've made statements of concern as well. And that group includes our former Prime Minister, Helen Clark. There's also concern that experts might be underestimating the progress. In a recently published study, I won't go into the details, but just to summarize that the experts had not appreciated how advanced LLMs were in terms of getting up to the level of top performing virologists. They really underestimated that development in that recently published work. And also the companies themselves have been recently ranked by the Future of Life Institute in a report just last month. And they looked at the major companies in terms of how they scored on AI safety in an index that's been developed, and they all scored pretty poorly. The highest was Anthropic with a C+ grading, right down to an F for the two Chinese companies. And in terms of biorisks, experiments done by the companies on biorisk, the only work had been done by Anthropic. So a very much a neglected area, AI safety and particularly biorisk components of AI safety. So really, the concern is the integration between artificial intelligence and the life sciences. And the Nuclear Threat Initiative has just published a statement on biosecurity risks at the convergence of AI and life sciences. And they really highlight that these AI and bioscience tools can simplify pathogen design and lower barriers to designing dangerous biological agents. And the greatest concern here is about governments, actually. A recent study highlighted that when they compared it with the capacity of non-state actors to do these things. And so, yes, there's concern about accidental release, as Rainer talked about, and also deliberate misuse and risking a global biological catastrophe. And so the concern here is that we're raising the ceiling of potential harm. So AI could design pathogens that are more dangerous in terms of virulence and transmissibility than natural ones. It can already produce genomic sequences that can encode new viruses or weaponize existing agents, such as smallpox. It can also do work on designing individual biological molecules, so new toxins or proteins that are part of existing pathogens, or proteins that combine on important targets in the body, and even the possibility of designing whole groups of biomolecules that could work together to disrupt cell signaling in the human body. And so the National Threat Initiative report seemed to think that a lot of these concerns are just going to be plausible within just a few years. And other work by the RAND Corporation for the US government also has looked at the possibility of AI designing and releasing multiple simultaneous pandemics if it attempted a takeover scenario. So more specifically, in terms of the rise of autonomous AI agents, so you can see with recent releases of large language models, agentic capacity has been increasing, and but whether that's at a very high risk level, it's still somewhat uncertain about the capacity of these agents. But we know now that agents can assist with literature reviews, hypothesis generation, designing lab experiments, interfacing with bioscience lab equipment, and even working with advanced laboratory robotics. And so these could be used in misused or act in unintended ways. And so as well as this autonomous agent development, we do have also the rapid development in life science applications. And so in terms of the specific issue of autonomous AI agents and wet lab interaction, so this is already happening to some degree already. AI can automatically work with lab robotics, but that's not even needed to generate a high risk scenario. If the AI can trick or bribe or blackmail laboratory workers to do things that the AI can't do in the lab by working with humans. And in a recent report by Anthropic, they ran experiments, and in all the large language models they tested, I think it was about 8 of them, in each experiment, the LLM would resort to blackmail as a last resort when it was being threatened with being turned off or having its goals subverted. So at the extreme end, when they're under forced, the ethics built-in features are overridden by the large language models attempt to survive. So that makes blackmail risk a possibility. And AI and bioscience together can potentially undermine biosecurity defenses. It could contribute to circumventing nucleic acid synthesis screening by designing synthetic homologs. So rather than the precise DNA sequence of concern, it creates a different DNA sequence which can do the same thing, enabling resistance to countermeasures, building in resistance to potential vaccines or antivirals, and evading biosurveillance systems for detecting actual outbreaks when they occur. And misaligned artificial intelligence could go further if it was also doing disruption in terms of fermenting discord or increasing distrust if an outbreak had started. So what are the options in terms of reducing these risks? What are the primary prevention aspects? Well, we've got a lot of problems in the world at the moment, and it's sometimes called a global meta crisis or polycrisis, and we really just need to do far more to have system-wide solutions to deal with catastrophic risks, climate disruption, conflict and trade wars, and poverty and inequities. So we need international treaties around advanced AI for governance and to build guardrails and verification and enforcement mechanisms. We need to upgrade and strengthen the Bioweapons Convention. It's had no major upgrade since 1972, and it's extremely weak on enforcement. In fact, we need a whole of society approach. We need governments, industry, academia, civil society, the philanthropic sector, to all help with tracking evolving AI and bioscience developments and risks, and to balance the risks with the potential benefits of AI and the benefits of biotechnology. So there's complex trade-offs that society may need to make if it's going to get the benefits without these very high potential risks. And so we need things like citizen assemblies, citizen juries that have deliberative democratic processes to actually see how tight the regulation should be to control these concerns. Some specific examples of primary prevention: we need to really reduce the information hazard around permitting open weight LLMs. We need to tighten laboratory safeguards, and Raina talked about some of those things. We need to upgrade DNA synthesis screening systems using encryption and international network servers, and Esvelt and colleagues have described a lot of those things. And also in the literature, you can see good ideas for new regulations and criminal offences to tighten up the very loose regulatory systems we've got. But also, if prevention fails, we need surveillance, border controls, and public health and social measures to control any outbreaks. We need to look at enhancing surveillance and rapid diagnosis. And in fact, AI can help with this. It can be used for metagenomic early warning systems using sewerage. We've made a lot of progress in these type of developments, but we need to keep advancing them. In terms of border control, there's been work done on how to have kill switches to turn the internet off, and that's particularly relevant to island countries that are connected with cables, but it would have to apply to satellite connections as well to avoid concurrent AI attacks or cyber attacks. And border controls are particularly relevant to island nations where work we've done has shown that the COVID response was significantly stronger in island nations, and so they're well placed to deal with pandemic risks. And we need to be able to eliminate or mitigate any spread with state-of-the-art public health and social measures. So in terms of eliminating or mitigating extreme pandemics, if border closure fails, we need to attempt elimination. We may need very stringent stay-at-home requirements where all really essential workers have PPE and can continue to deliver the food supply and keep the grid functioning. If Mitigation is required. We need state-of-the-art public health and social measures with appropriate legal frameworks, high quality communication to the public. And we need to be able to develop new therapeutics and vaccines. So to wrap up and conclude, there's now a lot of expert agreement on there being potential catastrophic risks associated with AI and bioscience, but there is high uncertainty about clarifying those risks. Very rapid progress, both with AI and bioscience and the integration of the two. The risk may be increasing with these advancements, and that includes advancements in robotics. We need to address the global meta-crisis, polycrisis, but we also need specific international action for primary prevention. We need very good treaties. This is a global problem. We need very good governance. And unfortunately, the world is really lacking these things at the moment in so many areas. And unfortunately, we need to be prepared if prevention fails. So we need enhanced surveillance, capacity for good border controls, and very state-of-the-art public health and social measures. So thanks, and happy now to hand over to question time.
Thank you very much, Nick.